So this is mathematical logic. I hope you can see what I'm writing. Good. Yeah, yeah. So the objective of this session so by the end of the class or the lesson, we should be able to first define what logic is. Then number two, define what is a proposition. What is truth value? Truth table. What is an atomic or a simple statement? And then also, we should be able to define and discuss logical connectives. And we only have 5 logical connectives. So we have what we call negation. There's what we call conjunction. There's what we call disjunction. There's what we call implication or conditional. Then lastly, biconditional. So these are the only three objectives that we have to achieve in this lesson. And as I said earlier on, please remain attentive throughout the class. Being the first time we are introducing this chapter, it may be the first time you are hearing of mathematical logic, but the topic is very, very friendly and very, very interesting, only if you are going to be attentive and follow from the start the basic definitions, because later on we'll now be coming back to discuss different ways of combining these logical connectives. So ensure that you understand the definition of each term and the notation and how it is applied. So we begin by defining what logic is. So definition. So mathematical logic is a study of the processes used in mathematical deductions. And the origin of this topic is from the field of philosophy. So those who are doing philosophy as a subject area, this is actually the origin of the genesis of the topic of mathematical logic. So the subject originated from philosophy. So the next we define a proposition. I know some of you are doing communication as a major. Please do not, this term is not preposition, it is proper. So don't confuse it with your English term, prepo. We are not referring to this. It is proposition. So a proposition is a declarative sentence which is either true or false, but not both. So a proposition is a declarative sentence or an assertion which is either true or false, but not both. So these are very key terms in this definition. Either true or false, but not both. And then it is something or a sentence that declares. So an assertion or a declarative sentence which is either true or false is what we call a proposition. And then another term which can also mean proposition is statement. Propositions are also called statements. So throughout this chapter, the word proposition and the word statement will be used interchangeably to refer to the same thing. So they are synonyms. So just recall from your English classes, we have different types of sentences. So can you tell me any class of sentence that you discuss in your English classes? Apart from declarative sentences, then other types of one? So we have what we call declarative. So these is declarative are what we call assertive types. Then apart from declarative sentences, any other example of sentence that you know in English? Interrogative. Correct, interrogative sentences, then two, interrogative. So interrogative are which type? Asking questions. Yes, question type. Any other? Apart from interrogatives, declarative. Command type sentences are called imperatives, correct. Yeah, so we have what we call imperative. Imperative is command type. Command or request type. Then those which express emotions or excitements. We can have this exclamatory. So these are emotion or excitement type. And some are what we call open sentences. So in these 5 classes of sentences, only the first one is what defines a proposition. Only sentences which lies in this class are those which define a proposition or a statement. But these other types, interrogatives, imperatives, exclamatory, and open sentences, they do not define statements or propositions because they can't be classified as either true or false, but not both. So therefore, when you have been asked to do classification of sentences as either being statements or non-statements, the nature of the sentence will actually tell you whether it will be classified as a statement or not. Those which will be classified as statements will be those which are assertive or declarative. Otherwise, they are not. So example, classify the following as statement or non-statement. So it's a very easy exercise. You say a statement if the truth value, if it is either true or it is false, and not both at the same time. So the first one, Mount Kenya is in Uganda. Then number 2, 3 plus 4 is 34. Number 3, 6 plus 5 is less than 20. 4, punguzeni your volume. Give me that book. Number 5, how beautiful this flower is. So this is an exclamation mark. And then number 6, where are you going? Number 7, wish you success. Number 8, this is the beginning of the end. Number 9, Eric is left-handed. Number 10, he is left-handed. Then number 11, x plus 4 equals to 20. Number 12, x plus 4 equals to 20 for some integer. So the goal of this example is to classify a sentence as either a statement or proposition or non-statement. I remember we have said a statement or a proposition is a declarative sentence that can either be classified as true or false, but not both. So when you say Mount Kenya is in Uganda, is it a statement or a non-statement?
Statement.
Statement. What is the truth value of that statement? It is false. We know Mount Kenya is in Kenya. So when you say Mount Kenya is in Uganda, then that's false. So when get it clearly from the word go, when we say Mount Kenya is in Uganda is not true, it's false, then does not mean it is not a statement. It only means that it is a sentence which is always false. And because it is always false, then it qualifies to be called a statement. Because a statement is both can be true or can be false, but not both. Good. 3 plus 4 equals to 34. Statement, correct. What's the truth value of that statement? False. We know 3 plus 4 is 7. It's not at 4. Correct. Then 6 plus 5 is less than 20. Statement, true or false? Always true, yeah, because 6 plus 5 is 11. 11 is a number less than 20, so that's always true, correct. Give me that book. Statement or non-statement? Why? It sounds like a command, okay? Yeah, and commands are not declarative, so this is not a statement, correct? So this is not statement, this is non-statement. Commands are not statements, or they can be classified as true or false. Not both. How beautiful is this flower? Non-statement, even from the punctuation itself, when you see an exclamation mark, then already it can be a statement. So this is non-statement. Where are you going? Statement or non-statement? Non-statement because of even the punctuation, the question mark. All questions are not statements. This is non-statement. Wish you success. Non-statement. So wishes are not statements. Then this is the beginning of the end. non-statement. So this beginning of an end is a paradox. Paradoxes are not statements. So this non-statement. Then number 9 and 10 are very interesting. Eric is left-handed, and then 10 says he is left-handed. So are all of them statements, or one of them is a statement, another one is not, or both of them are not statements? Both are statements? And then the second one? When you say he's left-handed? When you say he's left-handed, then what do you think is the verdict on that? So both of them are statements. Okay. Anyone with a different opinion? Okay, when we say he is left-handed, who? Okay, if I may ask the same question, when you say Eric is left-handed, who? Eric. Then now, he is left-handed, who? So he means who? Is he your brother, your dad, your grandfather, your male cousin? So whom are we referring to? A male person. So after many male. So he means male. And male can be anything. Can be Joseph, can be Vincent, can be John, Derek, James, Michael, Eric, your dad, your brother, your male cousin. It's too general. It's not specific to whom we are referring to. So we cannot quantify as being either true or false, because that he can be replaced by anyone, provided the person is a male person. So Eric is left-handed. We are specific to the person we are referring to. So it can either be true or it can be false, but not both. We are sure for any normal person, either left-handed or right-handed. So this one is a statement. But here, this is a non-statement because when you say he is left-handed, this word he is a generality which can be replaced by anyone who is a male, and it will bring mixed interpretations. So it's an example of what we call an open sentence. We are left with all options to fix for this he. But Eric, we are specific to the person. 11, x plus 4 is 20, and 12, x plus 4 equals to 20 for student. So are you able to do the classification for that? With the reasoning in 9 and 10? 12? A statement, correct. So 11 is an unstatement, is an open sentence. Just the same way we were interpreting 10. So x can be, this variable x can be replaced by anything. When you say x plus 4 equals 20 and you keep quiet, then we are left to have all options to fix for x. And so open sentences are not statements. So these are non-statement. But here we are being guided on what we need to fix and fix for x, a specific integer. So when you go and pick one integer, you put there, then you classify that thing as either being true or false, but not true and false at the same. So these are statements. So the main take home here is that what is classified as a statement or a proposition is what can be classified as true or false, but not both. And then the other thing, interrogatives, imperatives, open sentences, and exclamatory sentences, all of them are not statements. Then we give another definition, what we call truth value. So the truth or falsity of a proposition is called its truth value. So the truthness or the falseness of a statement is what we call its truth value. Then the truth value of a statement is either true and when it is true, we denote this by capital T, or we use digit 1, or false. And when it is false, we denote by capital F or digit 0, but not both, as usual. So if a statement has a truth value of true, then we use T or we use digit 1. When it has a truth value of false, then we use capital F or 0. And then if you remember the way we introduce sets, we say that we name sets using letters. Similarly, we name statements using letters. So propositions, using letters, e.g. A, B, C, or you can decide to use uppercase letters, A, B, C, or you can even decide to use subscripts, letters with subscripts, say A1, A2, etc. So for example, we can say Mount Kenya is in Uganda is a proposition. We are giving it a name A. So A is a proposition, Mount Kenya is in Uganda. So we write the letter, colons, and then write the statement. 4 plus 3 equals to 53. Say that's the name we give to statement 4 plus 3 equals to 53. And then say tomorrow is my birthday. Today is Monday, etc. So that's what we have. So we write the letter columns and then write the statement weighted. Oh, no, let me change it. Then change it. So the next definition is what we call truth table. So a truth table is simply a table that summarizes the truth values of statements. A table that summarizes truth values of a proposition. A table that summarizes the truth values of a proposition is called a truth table. Then note if a proposition has n variables, or letters, then the number of rows in the truth table is 2 power n. So for example, here, if a statement with one variable has 2 power n, which is 1, which is equals to 2 rows. So this is what we mean. So we say that a statement can either be true or it can be false. So if the statement is P, then P can either be true or it can be false. So we'll have these two rows, this first row, this second row. So with two statements or variables, say P and Q, then the truth table has how many rows? If I have two statements, or a statement is two variables, how many rows are we expected to have in the table? 4, because you have 2 power 2, correct? So it has 2 power 2, which is 4 rows. So this is how you begin. you say, by default, any statement can either be true or it can be false. Then we have 4. So 4 divided by 2. 2. So I'll have you put 2 here, 2t, 2f. Then again, a statement can either be true or it can be false. Statement can either be true or it can be false. So when you are drawing, you have P, you have Q. So you'll have 1, 2, 3, 4 rows. Then this first column, you put 2 T's. So T, T, then 2F, F, F. Then in this other column, you just follow the order the way they are here. So you have T followed by F, followed by T, followed by F. Then number 3, with 3 statements, or variables, we have how many rows? 8 rows, correct. Or we have 2 power 3. 2 power 3, which is 8 rows. So then this is how you start. So by default, a statement can either be true or it can be false. So there are 2 options. So 8 divided by 2. 4. So we have 4. We have 4 here. Then again, a statement can be true or false, true or false. Then 4 divided by 2. 2. So this is 2, this is 2, this is 2, this is 2. Then finally, a statement can still be true or false, true or false, true or false, true or false. So when you are drawing your table, so if we have variables P, Q, and R, then 1, 2, 3, 4, 5, 6, 7, 8. Then when you are filling this first column, you start with T 4 times. So we have T, 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 followed by F 4 times, F, 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 F. Then in the second column, you write 2 T's. So T, T, followed by 2F, F, F, followed by 2T, T, T, followed by 2F, F, F. Then finally, the last column, you just follow this order. TF, 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 TF. Then you can extend to as many statement variables as you can. Ask. Yes. For this case or the other cases? This case 3 or the previous 2 cases? Okay. So, this is the reasoning. From the word go, we said a statement or a proposition is what can be classified as true or false. So a statement has any of the two possibilities. It can either be true or it can be false. If I can remind you what you're doing in high school, a coin has two sides. There's a tail and a head. So when you toss it once, you can either get a head or you can get a tail. So the same. So here now you can either get T or it can get F. So because we have already known from the word go that if you have three statement variables, the number of rows you expect to have in your two table, they must be 8. So the first thing is that a statement can either be true or a statement can be false. So there are two possibilities. So if you have 8, when you divide by 2, 4, 4. Then you go further and split. It can also either be true or it can be false. It can either be true or it can either be false. Here you have 4. When you divide by 2, you get 2, 2. 4, 2, 2. Then finally, 2 divided by 2 is 1. True, false, up to the last one, true, false. So once you have this structure, this is what forms the first column. This result is what forms the second column. And this is what forms the third column. That's what we are doing here. Don't know if I'm making sense to your question. Okay, good. So let's define what we call a simple and a compound statement. So simple and compound statements. So any statement which cannot be split So any statement which cannot be split further into two or more other statements is called a simple or atomic statement. Then if a statement is formed by a combination of two or more statements, then you form what we call a compound or a molecular statement. A compound or molecular statement is a statement formed by a combination of two or more simple statements. So the examples we have discussed earlier on are examples of atomic or simple statements. So we'll see examples of compound statements after defining the logical connectives. So logical connectives are the words or the tools we use to connect two or more atomic statements to form what we call the compound statements. So logical connective. So a logical connective is a word or a sign used to connect two or more atomic statements to form a compound statement. A logical connective is a word or a symbol used to connect or join two or more simple statements to form a compound statement. So they include so we have negation, we use this sign or this sign, disjunction, conjunction, then we have disjunction, then we have implication, or what we call conditional, and we have lastly what we call biconditional. So I give 5 minutes break, then we come to finish up the discussion on these 5 connectives. So let's continue. So let's continue. Oh, I didn't huko. The first one, negation. Oh, I didn't huko. Sitaki kuwataki hapa. So let P be a statement. So let P be the negation of P denoted by the negation of P is the statement, not P. So simply you are denying P or opposite of P. So for example, find the negation of, so the first statement, let's say it is raining. Then the second statement, today is Monday. The third statement, 4 plus 6 equals to 3. D, be the statement, tomorrow is my birthday. And let E be the statement, sugar causes to decay. And please, as we agreed earlier, do not say the obvious. We give the answers with respect to the definition we have given. So we are saying the negation of a statement P is the statement, not P. We simply mean that we are denying P. So when we say it is raining, to deny that statement, you say, correct. So the negation of A will be written in this form, and then the answer will be, it is not raining. And when you are responding to problems in this chapter, we are usually very, very sensitive on punctuation. So the things they mark in your essays, we still mark them here. So where there's a full stop, ensure you put it appropriately. Where there's a comma, put it appropriately. And where there's a capital letter, put it appropriately. We respect all those punctuation when you have given your answer. So the answer will be, it is not raining. Good. Then negation of B will be the statement. Today is Monday. So what would be the negation of that statement? So don't put away if I was not in the question. So just respond it to the way it is. Don't be very creative. If you become creative, then you mess it up. So the answer will be today is not Monday. Don't add a Monday if I was not given in the question. Then 4 plus 6 equals to 3. To deny that, you say? Correct. 4 plus 6 is not equals to 3. And then tomorrow is my birthday. Will be? Correct. Tomorrow is not my birthday. And then sugar causes tooth decay. Negation will be? Correct. Sugar does not cause tooth decay. So that is how we find the negations of statements. Just as simple as that, to deny the statement using the word not. So please note, the negation of a statement P can also be defined as it is not the case that P. So that's also how we can also give the define the negation of a statement P. So for example, A was the statement, it is raining. So if I was to use this definition, I will say the negation of A can be written as it is not the case that it is raining. So that is how I can provide the same negation for statement A. Then what if we want to use the same definition to define the negation of B? How else can we say it? B is today is Monday. No. Yes, remember I said, please don't be creative. Be stupid and follow the definition given the way it is. So remember, we are saying this other structure of giving the negation is the stem. It is not the case that P. So all these things should actually be seen. Don't pick some words and then leave some. You'll actually be creating your own definition. So the answer will be it is not the case that today is Monday. And when you are asked an exam, please you don't have to give the two options. Just stick to one. Don't give the answer using the stem. It is not the case that P, and also using the not P. Just pick one and then it will be enough. So I'm giving this other way so that actually you actually know that there's still another way of giving the same answer. Now, 4 plus 6 equals to 3 will be? Correct. Yeah, that's how you can write it. Then truth table. So truth table, you write statement P, a negation of P, then P can be true or it can be false. Now, maybe for us to fill that table, let's say, when we say, according to where you are, the statement it is raining, is it false or true? At this moment. So where you are is false. So when you say it is not raining, what would be the truth value of that statement? True. So that becomes true. Then today is Monday. What is the truth value with respect to today? True. Then today is not Monday. False. 4 plus 6 is 3. False. When you say 4 plus 6 is not true. Then tomorrow is my birthday. Now, remember, all of us have different birthdays, but this is what the respect to actually the person saying it. So, like for me, tomorrow is not my birthday. So the truth value of this one is F. So when I say tomorrow is not my birthday, then it becomes true. But it's possible that another person can have tomorrow is my birthday to be true, and the negation will now be false. But what we are sure is that for one individual, it is not possible to say tomorrow is my birthday to be true and false at the same time. It will have just one answer. That's why it's classified as a statement. Sugar causes tooth decay, true or false? True, these are scientific results. Then when you say sugar does not cause tooth decay, false. Good. So from those few examples, what can you say, or what can you say with respect to a statement, the truth value of a statement and the truth value of its negation? If a statement is false, then its negation will be true. And when a statement is true, its negation will be false. Correct. So therefore, in the truth table, if the statement P is true, then its negation must be false. And when a statement P is false, then its negation must always be true. Then next, next number 2, conjunction. So conjunction, we use this notation. Now, for us to define a conjunction, we require 2 statements. So in the definition, we'll need 2 statements, say P and Q. So we say let P and Q be 2 statements. Then the conjunction of P and Q, usually denoted by either statement P and Q. So that's how we define conjunction of two statements. The conjunction of two statements, P and Q, is the statement P and Q. So for example, if A, the statement, it is raining, B, the statement, today is Monday, C, the statement, tomorrow is my birthday, and D is the statement 6 plus 5 is 65. Then what will be the meaning of this statement? Who can tell us the meaning of that statement from the definition? And please, as we agreed, do not. Everything stems from the definition. So then, which means now with respect to what we have, correct. It is raining and today is Monday. That's the meaning of this statement. It is raining and today is Monday. Good. Then, what will be the meaning of the statement? What do you mean? This I've already I've duplicated the same thing. So this should be C. This will mean correct. It is raining and tomorrow is my birthday. Proper punctuation. Then the next one. If we have then it will mean just unmute and say, ask. So here, remember here, what we respect is the definition of what we are defining. We are defining a conjunction. And we are saying that if we have two statements, P and Q, the conjunction is the statement P and Q. Don't introduce other things in this one. Use only that's the conjunction that you are interested in. Joining two statements using the word and. So do not care about the truth value of the statement itself, whether it is true or it is false. That's not your problem. What you are just doing here is to join two statements using the word and. Correct. So tomorrow is my birthday. And 6 plus 5 equals to 65. You have asked a good question. Please, from the question which has just been asked, just answer what you have to answer. Don't be smart and now say 6 plus 5 is not 65, and then now you negate it. You'll be answering your own question. Just respond to what has been asked for you. Here, we are interested in the conjunction. We don't care the truth value of the statements given. So what you do, you are joining the two statements using the word and. I hope that is in order. Are we together? That? Good. Yeah, so then truth table. So if I have two statements, P and Q, how many rows do I expect to have? In my truth table? 4, correct. So then I have P, Q, and then P and Q. So 1, 2, 3, 4. So true, true, false, false, true, false, true, false. So for conjunction of P and Q, when P is true and Q is true, then P and Q becomes true. When P is true and Q is false, P and Q becomes false. When P is false, Q is true, P and Q becomes false. When P is false, Q is false, then P and Q is also false. So what summary can you make from this table we have drawn here? Like when someone asks you if you are discussing about conjunction of two statements, when do you know that you get a P as the final answer? Or when are you going to get an F as the final answer? Otherwise? Correct. So then you say NB conjunction of two statements is only true when both statements are true otherwise you get false. Then third last, disjunction. So disjunction, we use this sign, capital V. So to define a disjunction, you also require two statements. So you say let P and Q be two statements. Let P and Q be two statements. The disjunction of P and Q denoted by either statement P or Q. So once we have defined, we give examples and then draw truth table and then go to the next. So for example, if I have A, the statement tomorrow is my birthday, B, the statement it is raining, C, the statement 3 plus 4 is 9, and D, be the statement all dogs are black. Let's consider these four statements. Then who can tell us the meaning of this compound statement? Correct. We don't complicate the obvious. Just follow the definition. So the answer will be tomorrow is my birthday, or it is raining. Good. Then what will be the meaning of the statement? Correct. 3 plus 4 equals to 9, or all dogs are black. So what we're simply doing on disjunction, we are taking the first statement, delete its full stop, join using the word or the second statement. Then you do the proper punctuation. Then truth table. So P, Q, P or Q. We still need 4 rows because we have 2 statements. So this is true, true, false, false. Then here we have true, false, true, false. Now, when you say true or true, we'll give true. True or false will give true. False or true will give true. False or false will give what? False, correct. False or false will give false. So what summary can you make from this table? If someone asks you to draw a disjunction truth table. You will always get false when both statements are false. Otherwise, true, correct. Yeah, so that's the main take home from this table, that NB, a disjunction of two statements is only false when both statements are false otherwise it will be true. So that's the main take home. Then the second, before we go to second last, consider this. If I say applicants for this job should have a first class honors or a 2-year work experience, and then two, tomorrow I will go to school or attend my grandfather's funeral. So I want us to interpret the use of the word or in these two statements and see whether they mean the same. So in the first statement, there's an aspect of someone getting a first class honors, and there's an aspect of a 2-year work experience. So first class honors, 2-year work experience. Okay. Let's interpret different scenarios for this job advert for applicants. So if someone has a first class honors, but they don't have a 2-year work experience, do they qualify for this job as per this advert? Okay. If this another applicant fails to have a first class honors and they have a 2-year work experience, do they qualify? They still qualify. Now, if a candidate has a first class honors and at the same time they have a 2-year work experience, do they qualify for the job? If they have both first class and 2-year work experience, will they still qualify? They still qualify. Okay, let's go to case two. Case two, tomorrow I will go to school. So there's aspect of going to school or attend my grandfather's funeral. So there's attending funeral and then going to school. Let's go to things that this person will do when tomorrow comes. When tomorrow comes and this person go to school and fail to attend the funeral, will it be in agreement to what they initially said? If they fail to attend the funeral but go to school. Okay. Then when tomorrow comes and this person fails to go to school and attend the funeral, will it still be in agreement with what they said? Okay. Now when tomorrow comes, is it possible for this person to go to school and attend the funeral at the same time? It's like it's not possible, okay? It's like here, unlike in the case one where someone having both first class and work experience qualify, the second one does not allow this person to go to school and at the same time attend the funeral. But you see, in both cases, we are connecting the statements by the word or. But they are turning out to give to these two situations. And generally, this word or has two dimensions. There is the inclusive aspect and there's an exclusive aspect. So like in the case one, the or used in one has an inclusive aspect to mean that both activities of both properties will still hold and will still be achieving the objective, or is still a good case scenario. But in the second case, we are not allowed to participate in the two activities at the same time. So which means that we are being forced to actually choose one, not both of them. So the same way or behaves here is the same way disjunction behaves. So disjunctions, there are two types. There's what we call inclusive disjunction. And when we say inclusive disjunction, is that the same disjunction you have defined by default. So we use this sign. And then there's an exclusive disjunction. Which will use this sign. So exclusive disjunction do not allow all the activities to be done simultaneously. The only best case scenario is one of the two activities happening, not both of them. So exclusive disjunction so let P and Q be two statements. The exclusive disjunction of P and Q denoted by so we write this, or we write this, put a bar on top of this sign, or we write this, a circle, and then we write a plus sign inside. If the statement P or Q, but not both. If the statement P or Q, but not both. So for example, if I say A, the statement, it is raining, and B, the statement, today is Monday, then this statement will mean it is raining or today is Monday, but not both. So the truth table I have P here, Q, then P or Q, but not both. So first row, second, third, fourth. So true, true, false, false, true, false, true, false. Now for the exclusive disjunction, the only base case scenario is when we have opposite truth values. When one is true, another one is false, or another one is false, another one is true. Otherwise, the other cases will give you an F. But when you say, tomorrow I will go to school or attend my grandfather's funeral, when tomorrow comes, you will only do one of the two activities. You either go to school and then forego attending the funeral, or go to the funeral and forego the school. So those are the only two best case scenarios that can happen. You cannot be allowed to go to the funeral and also to be at the school at the same time. And when tomorrow comes, you will not fail in doing any of the two activities. So what summary can you draw from this table? When do you get T or when do you get F? There are two ways of interpreting it. Either when to get F or when to get T. What summary can you draw from this table? Mm. Mm. So in simple terms, NB, the exclusive disjunction of two statements is only false when both statements have the same or identical truth values. When I say that, it makes sense. When you say identical, we mean either of them can be truth or all of them can be F. Okay? Are we together? Or now, if someone now wants to explain in terms of it is always true, what would be the statement? If you want to make summary in terms of that, it will only be true when what happens? Yeah, when you have opposite truth values, okay? Or another way of making that summary, you can as well say uh, it will only be only true when there's two statements have opposite truth values. So when you say have opposite truth values, mean that one is true, another one is false, and vice versa. Then the second last one is conditional. Conditional is also called an implication. So to define an implication, you require two statements. So let P and Q be two statements. The conditional or implication of P and Q denoted by so you write P, then you write an arrow Q, or sometimes we can write this. Is a statement if P, then Q. If P, then Q. And when we write P is called the hypothesis while Q is called a conclusion. Or consequent. So the starting statement is called the hypothesis. Then the ending statement is called the conclusion. So for example, if I have a statement A, it is raining. I have a statement B, today is Monday. I have a statement C, tomorrow is my birthday. And we have a statement D, 6 plus 3 is 10. Then can you be trusted with the meaning of this statement? Remember we said this means if P, then Q. Correct. If it is raining, then today is Monday. Please, I know this class has students who are doing communication and they are very good at English language. Please forgive us. Things we write here may not be making sense when you form our compound sentences or statements. They may not be making any sensible sentences in real world. But what we care here is the logical connective we are discussing. Like raining and today being Monday may not have anything in common for us to form a compound sentence or statement. But here it is correct because we are trying to interpret this logical connective. So don't read too much into the statements we are writing because they may not be nice to your area of specialization. What we care here is the logical connective we are trying to define. So that's the main thing. Then what will be the meaning of this statement? Correct. Yeah, you see, tomorrow being your birthday and doing the mathematics 6 plus 3, getting the answer be 10, for sure there is no relationship. But the answer you have said is correct because that is, we are interested with this operator here. So if tomorrow is my birthday, then 6 plus 3 equals to 10. So that'd be the correct answer. So just before we draw the truth table, also note the statement if P implies Q, if P then Q also means P implies Q. So instead of reading this one as if P then Q, you can as well read it as P implies Q. So for example, this statement here, when I write this, I can as well say it means it is raining implies today is Monday. So there's two still meaning. So when we say P, if P then Q, is the same thing as saying P implies Q. Then it also means P only if Q. It also means P is a sufficient condition for Q. It also means Q is a necessary condition for P. Now, the reason as to why I'm giving other versions of the interpretation of what we are defining is because sometimes you may be given a word statement and then they ask you to convert into symbolic form. So you should be able to know all those different versions of defining the same operation. So lastly, truth table. So how many rows do you expect to have in this case? How many rows are we expected to have? How many? How many rows? There are still four because there are only two statements, P and Q. Correct. So true, true, false, true. False, false, not true. So double truths and double false in the first column. Then true, false, true, false. Then this is how the final results look like. So we have true, false, true, and true. So the take home is that an implication is only false when the hypothesis, remember hypothesis, the first statement is true, but the conclusion is false. Otherwise, what do you expect? Otherwise, we have from the table. True, correct. Otherwise, we have true. And so when you are drawing or interpreting an implication or a conditional, you only have to observe the statement, the first statement, I then identify where we have a t value in your starting statement, then compare to the last statements or the conclusion. And if you find that the starting value is t and ending value is f, then you conclude that the final answer is f. Now, once we have done that one, then there is t without really caring. So the key thing is that you just observe that you are starting with a t value and then you are ending with an f value. That is what guarantees an f. But if that is not the case, then the rest of the positions should be given by t values. The last logical connective is biconditional. So also to define a biconditional, you require two statements. So let P and Q be two statements. The biconditional of P and Q denoted by so here now we have double arrows. Is the statement P if and only if Q. P if and only if Q. So the key defining term here is if and only if. So for example, if I have a statement A, it is raining. I have a statement B, today is Monday. I have a statement C, 3 plus 6 equals to 10. I have a statement D, tomorrow is my birthday. Then, are you able to explain the meaning of this statement? From the definition. Correct. It is raining. If and only if today is Monday. I still say my friends who are doing languages, your specialization, please forgive us. Things we are writing here may not be making sense uh, in real language world, in terms of what they have. That being manned and raining, there may be no much association. But what you care here is the connective. And this statement will mean remember everything stems from the correct. 3 plus 6 equals to 10 if and only if tomorrow is my birthday. This compound statement just makes sense in mathematics. I know those who are doing communication, if you write such a thing, they may not make, So other interpretations. the statement also means P is equivalent to Q. Or we can say P is a necessary and sufficient condition for Q. That's also the interpretation of that. So lastly, the truth table. How many rows do you expect to have? How many rows are we expected to have? For this? How many rows? Are you still alive? Hey, but you're not telling me that you are stealing from the university. What you paid is less than what we have covered. What you paid is less than what you have covered. It's past time. You paid for 2 hours, isn't it? Next week we have to take our minutes. You only paid for 2 hours. So let's just do this one and then we stop. Too bad that you have stolen from university like 20 minutes. So true, true, false, false, true, false, true, false. So for the biconditional, you only get true when you have either true, true, or false, false, but you get false when you have a mixture of T and F. So the summary here, biconditional is only true when the truth value of the simple statements are identical. Otherwise, false. So that's what you have. So I'll be sharing the notes and the recordings. Ensure that you update your work so that next week when you meet in class, everything is up to date. Please spare some time and ensure that you update your work, because what we'll do next week will be now to discuss different ways of drawing truth tables and proving some results involving these logical connectives. So I expect everyone next week. Before you come, ensure that you have updated all the work from the introduction when we started to define what is our mathematical logic up to what we have done on biconditional. Write everything that you have done and get some time, go through what you've done so that you are able to draw a truth table for each of these logical connective. Because now what we'll do next will now to be combining different types of logical connectives and drawing truth tables and making some conclusion from the truth table that we'll be drawing. Are we together? That. Tunaelewana? Sawa, sawa. So we stop there and have a good day.